In this video, we're going to solve absolute value inequalities. There are a couple of complications we need to worry about when solving absolute value inequalities. Here are some steps for solving less than absolute value inequalities. You can refer back to those, and here are some steps for solving greater than absolute value inequalities. I will highlight one thing right now. There is kind of a shortcut to remember the differences between these two and how we write the answer. With less than, we can mispronounce that as less than. So focus on the word and there, so less than. And that reminds us that when we have the two parts to our solution, we want this and that. We want both. So we put them together in one expression when we're writing our answer, because we want this and that. So we mispronounce less than to remember less than. So we want both in one expression. Now for greater than absolute value inequalities, we can mispronounce that one as well as greater than. And that reminds us that when we write the answer for greater than or greater than absolute value inequalities, we keep our two parts separate for a solution and use the word or. So this or that. Anyway, these steps will make more sense later after we've done some examples. So here we have our absolute value all by itself on the left side. That's always the first step. And so we'll go straight to our answer. This is less than or equal to is less than. So this is an and situation. So we're going to write our answer in one expression. We'll go ahead and write this part here exactly like it is there, except without the absolute value bars. And then on the other side, with the inequality facing the same direction, we'll put the negative or the opposite of that number on the right side over here. And that's our solution. So n is in between negative 19 and positive 19, including those endpoints. Or we could read this negative 19 is less than or equal to n, which is less than or equal to 19. Now on our number line, that means our answers are going to be in between negative 19 and positive 19, including those endpoints because we have equal bars there. So I use closed points. And since n is in between those, we'll be highlighting the number line in between those two endpoints. There's our solution and the graph of the solution. Here's another one we just need to worry about writing our answer instead of isolating the absolute value. So we have absolute value of y is greater than 3. So our solution will have the word or in it. So we'll start by writing this inequality the exact same way it's written here, except without the absolute value bars. Then we have the word or. And then we will flip the inequality and change the sign of that number there. So we have y is greater than 3 or y is less than negative 3. And that's our solution. Now it's going to look different from the last one when we put it on the number line. So I'll just put our two endpoints here. Notice there's no equal bar, so we're going to have open points here. And then y is greater than 3, we're going to highlight everything to the right. Y is less than negative 3, so we highlight everything to the left. So with greater than absolute value inequalities, the arrows end up going to the outside. All right, here we have the absolute value of 8z is greater than or equal to 24. We have the absolute value isolated here, and it's a greater than or greater than inequality. So we are going to write two separate inequalities. I'll write it exactly how it appears there in the question, just without the absolute value bars. And I'll use the word or, remember great or then. We'll mispronounce that to remember we use the word or here. And then we have 8z. Now we do two things. We switch the direction of the inequality and change the sign of the number there. All right, we'll go ahead and divide both sides by 8. We'll do that over here as well. These 8's cancel. So we have z is greater than or equal to 3, or z is less than or equal to -3. So that's how we write our answer there. When it's or, we do not put our two inequalities together into one expression. We keep them separate. It's this or that. We'll go up here and graph it. So I'm just going to put 3 on here and -3. And we have equal bars. We'll do closed points. They fill those in because our endpoints are included in the solution. And or, let's see, it's either over here or over here. So z is greater than or equal to 3, or z is less than or equal to -3. All right, once again, we have our absolute value all by itself. This time it's less than or less than. So we are going to write this with one expression because we want this and that in the same expression. First, I'll write it exactly as it appears here without the absolute value bars. I'm going to leave some room on the left though. So we have n minus 12 is less than 2, just like it's written here. Okay, now I use that same, notice these are the same here, and I switch the sign of this number. Now really we switch the direction of the inequality, because notice up here it's about to eat the 2, and down here it's about to eat the n minus 12. So we did switch the direction of the inequality, just doesn't look like it because it's over here on the other side. Now when I do my inverse operations, I'll be doing them in 3 places, on all 3 sides. So I have 10 is less than n, which is less than 14. Right, so n is in between 10 and 14, not including those two endpoints. Continuing with the graph, I'll put my two endpoints on here. And we'll be using open points because we do not have equal bars. And n is in between 10 and 14. So I'll be connecting those in the middle. So n is less than 14 and n is greater than 10. So here we do not have our absolute value by itself. So the first thing we need to do is get that absolute value by itself. So I'm going to subtract 2 on both sides. Then I'll divide both sides by -7. Now when we divide both sides by a negative number with inequalities, we need to switch the direction of that inequality. And -91 divided by -7 equals +13. Okay, this is a less than or less than inequality. So this is an and situation where we put both parts in the same expression. So I'll start by writing a is less than 13, just like it is here, just without the absolute value bars. Then I put the same exact inequality here and switch the sign of the negative number and put that over here. So a is in between -13 and +13, not including those endpoints. No equal bars there. Put my endpoints on the graph. A is in between those, so I'll have open points and connect them. A is less than 13, but and a is greater than -13, so in between there. All right, here with this absolute value inequality, the first step is to get the absolute value by itself. So we have some inverse operations to do here. Okay, we have our absolute value by itself. This is a less than inequality. So less than, this is an and situation where we want this and that in the same expression. So the first time through here, I'm going to write this expression exactly like it is here, but without the absolute value bars. Then I put this same exact inequality on the other side here, switch the sign of this number, and here's my expression. Now we want to get z by itself in the middle here, so let's add 20 to all three sides. Then we'll divide all three sides by 4, and I have my expression. 3 is less than or equal to z, which is less than or equal to 7. So z is in between 3 and 7, including those endpoints. Go to my graph, I'll put those endpoints on the graph. Close points, because we do have equal bars in our solution here. And z is in between 3 and 7, so we'll go ahead and connect those. If this had been greater than or greater than, that's when the arrows would point to the outside. Okay, I hope these examples have been helpful. This is Mr. Ela, signing off.